NATO nations decided that the alliance will acquire the capability to defend European territory and populations against missile attack.
This animation illustrates how NATO's ballistic missile defense capability is designed to work in a hypothetical scenario. NATO conducts thorough planning to make the best use of all weapon systems and sensors under its command. First, the threat posed by hostile missiles is determined based on intelligence estimates of threat capabilities. Next, national critical assets and areas are identified, and a detailed defense planning process begins. Finally, ballistic missile defense assets are assigned specific roles. Early warning is provided by satellites to sea and land-based assets deployed as part of the defense design. When a ballistic missile is launched towards the alliance, the NATO commander is alerted as its heat signature is detected by an infrared satellite. That information is then transmitted to a ground station for analysis. Planning and analysis are led by NATO's Headquarters Allied Air Command in Ramstein, Germany. When the threat is confirmed, the information is sent to all appropriate command centers, sensors, and weapon systems. As the hostile missile continues its ascent, the engine concludes its burn. At that point, the infrared satellite can no longer detect it. Long-range sensors, such as the United States land-based ANTPY-2 and the Netherlands sea-based SMART-L radar, then detect and track the missile. They forward the information to the command and control system so that intercept solutions can be calculated. The NATO tracking capability also includes the U.S. Navy Aegis Combat System, featuring the AN-SPY-1 radar, which is capable of tracking more than 100 objects. Together, these sensors create a robust detection and tracking capability. As tracking continues, greater accuracy is achieved. The sensors follow the missile as long as possible and share updated information with all other systems. A key feature of NATO's ballistic missile defense system is an upper layer intercept capability aimed at destroying missiles outside the atmosphere. This is provided in part by the Aegis ships. In the future, additional systems like the Terminal High Altitude Air Defense System, or THAAD, could also provide additional capability. In our hypothetical scenario, one of the threat missiles is engaged and destroyed in space. Threatening missiles that do re-enter the atmosphere become the responsibility of lower layer elements such as the Patriot system used by Germany, the Netherlands, and the United States, and the SAMP/T system used by France and Italy. All sensors continue to track threatening missiles. As the threat comes into range, lower layer shooters engage and destroy any remaining hostile missiles. In November 2011, during the live-fire exercise Rapid Arrow, NATO commanders successfully tested essential elements of the interim NATO missile defense capability, using it to plan, coordinate, and carry out engagements against live ballistic missile targets. These were conducted by German Patriot batteries assisted by the U.S. Aegis destroyer USS The Sullivans and linked by the NATO and U.S. command and control systems. NATO participation in this exercise included several command elements. In Germany, the Headquarters Allied Air Command at Ramstein, and its subordinate command at the Combined Air Operations Center at Udom, and in Turkey, the Headquarters Allied Air Command at Izmir. During the live-fire portion of the exercise, small ballistic missile targets were fired from a remote island near Santorini in the Aegean Sea. The Aegis destroyer detected these targets and reported them by U.S. satellite communications to the United States 603rd Air Operations Center at Ramstein Air Force Base in Germany. From here, the track was forwarded to the NATO Combined Air Operations Center in Udom, Germany. The information was then sent to German Patriot units on the Greek island of Crete and to NATO's two Allied Air Command headquarters at Ramstein, Germany and Izmir, Turkey. When the German Patriot systems detected the target, they reported the track over a NATO satellite link through Verona, Italy, to the NATO Command and Control node in Udom. There, the NATO system integrated the data to create a real-time air and missile defense picture, which was forwarded to NATO's Ramstein and Izmir headquarters and to the USS The Sullivans. This made all the relevant command levels aware of the incoming ballistic missile in real time. Based on this information, the Patriot system on Crete successfully engaged and destroyed the hostile missile.
As this whole event only lasted about 5 minutes from the launch of the target missile to the final engagement, it also shows how critical a good functioning C2 system is to the overall command and control process. Here at Ramstein we could see everything, the detection of the launch, the tracking of the target missile going inbound into the target area, and then the engagement process.
Weapons and sensors contributed to NATO's defense by member nations, together with the NATO Command, Control, and Communications Network, have enabled NATO to develop a new ballistic missile defense capability. This significantly increases the alliance's capability to address missile threats and enhances the security of NATO populations, territory, and forces.